Our next unit, and probably our last unit, is probability. So we started off the year with statistics and we're coming full circle and wrapping it up with probability. Before we actually get into probability, we need to learn what are called counting principles because we use those in order to calculate probability. The first way we're going to take a look at how to count a certain number of outcomes is by using a tree diagram. So I have an example for you here, and it's just a visual representation of all possible outcomes for an event. So our first example is an event where you flip a coin twice. So the H represents getting heads and the T represents getting tails. So you can see that visual of heads, 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 tails, and so on. And a sample space is when you list all possible outcomes. So as I started talking through them, you can see them listed at the bottom there: heads, 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 tails, tails, heads, and tails, tails. So those are the only 4 possible outcomes for when you flip a coin twice. Now we're going to create our own tree diagram. And this example says we're going to roll a die. So we have to think about what are the possible outcomes when we roll a die. Well, they have the numbers 1 through 6 on the sides of a die. So that's the first possibility, and I'm just going to list those vertically, is you could roll a 1, 2, 3, 4, 5, or 6 when we roll a die. And then it said after we roll the die, we're going to flip a coin. When we roll a 1, we could then flip the coin and get heads or tails. If we roll a 2, we could then flip the coin and get heads or tails. If we roll a 3, the coin could come up heads or tails. And of course, the same thing could happen if we roll a 4. All right, my H's are having a little bit of difficulty with the tablet here. A 5 or a 6. So there's the tree diagram for our event, which was rolling a die and then flipping a coin. Now it asks us to determine total number of outcomes. Well, if we roll a 1, there's 2 outcomes, heads or tails. If we roll a 2, there's 2 outcomes, heads or tails, and so on. So we have a total of 12 possible outcomes when we roll a die and then flip a coin. Example 2, we've already got the tree diagram listed for us. This is different possibilities of lunch. So as we look at our tree diagram, it looks like we have 2 choices for a sandwich, ham or turkey. We have 3 choices for a side. We could get a salad, chips, or a cookie. And then we have 2 options for a drink, milk or soda. It's asking us to use the tree diagram to list out all possible options. Again, that's called our sample space. So we're going to be creating a sample space for different lunch combinations, and then we can count them up to determine how many different lunch options we could choose. I will abbreviate, and honestly, you guys, I have no idea why soda is on here because we're from Minnesota and we say pop. So I'm going to use P for pop because I'm going to use S for salad. So we could get a ham sandwich, a salad, and milk. Or we could get a ham sandwich, a salad, and pop. And then we have a ham sandwich with chips and milk, or a ham sandwich with chips and pop. And finally, we could get a ham sandwich. We already used C for chips, so I'm going to use a K for cookie and milk. Or a ham sandwich with a cookie and pop. Very similar options for that turkey sandwich. Turkey sandwich, salad, and milk. Turkey sandwich, salad, and pop. Turkey sandwich, chips, and milk. Turkey sandwich, chips, and pop. And finally, turkey sandwich, cookie, and milk. Or a turkey sandwich, a cookie, and pop. And finally, it says determine the total number of possible choices. So as we look down our list, we have 2 choices in each row, and we have a total of 6 rows. So the 2 times 6 gives us, once again, 12 total options for our lunch. Another way to get number of outcomes is to count the last column in your tree diagram. So we have 2, 4, 6, 8, 10, 12 possibilities for lunches. This last one, I want you to pause the video, list the sample space. I'm going to get you started, and then determine number of outcomes. I'm going to insert a question here so you can try it, and then we'll go through it and you can check your work. This tree diagram represents options for having 3 children. So if you have 3 children, one possibility is that you have 3 boys. Continue down the list, follow the branches for the tree diagram, and see how many options you come up with for a family of 3. All right, the next option is you could have a boy, boy, girl. The next row says boy, girl, boy, and boy, girl, girl. So those are the options for if your first child is a boy, and then the other 2 could be boys or girls. The second half of our tree diagram is if your first child is a girl. You could have girl, boy, boy, girl, boy, girl, 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 boy, and finally 3 girls. Now some of these might seem like they're the same. There's 2 girls and a boy, but as you know, if you have siblings, the order in which you are born does matter. So if the oldest is a girl versus the youngest being a girl, those are 2 different families. So we ended up with a total of 8 different possibilities for families of 3 children. All right, and I have another question for you, and this time my question is, what is the worst part of this quarantine for you? So for me, it is not being able to get my hair cut, because my problem is that I wait too long to get a haircut to begin with. So I probably needed a haircut back in February. And then in early March, I contacted my hairstylist to see if she could fit me in over spring break, and she couldn't. And by the time we got back from spring break, everything shut down and I've been unable to get a haircut. So it is absolutely driving me crazy. I'm really glad you can't see my split ends through the video because it's awful. So if any of you know someone giving bootleg haircuts, let me know. I need a haircut. So let me know, what is the worst part of this quarantine for you?